In this video, we want to talk about Python programming language and have a brief introduction to the language. We're going to be learning Python in this course, so I just want to touch on some of its basic concepts, introduce you to the language, and try to get you excited into what you're about to learn. Python Rossum in Netherlands. He created Python in 1991. Simpler language to read and easy to write, and based on the simplicity of Python from there, and it's been just a beautiful journey ever since. From 91 to now, lots of things on, lots of applications. It's really an exciting and fun language. Like I've said already, the syntax of Python is actually what sets it apart because it's a little more beginner friendly and still very versatile. Anything you can do in any other language, you can most likely do it in Python as well, and you definitely have an easier time writing the Python code as Python also comes with a very rich ecosystem, so you have lots of libraries and frameworks for scientific computing, making web apps, for AI, data science. In fact, Python is the standard language for anything machine learning, deep learning, and AI. You can also use Python to make desktop apps, mobile apps, everything. You can use it for networking. You can use it for cybersecurity tasks. You can use it for scraping the web. There's so much you can do with Python, one language to do a whole lot of stuff. So Python is a dynamically typed programming language. It means you can easily give a variable a different data type and then reassign that data type. So there are some other languages where if you want to define a variable, you need to go ahead and define the type of the variable. Say this is going to be a number, this is going to be a string before you even declare the variable. But Python is very easy because understanding the type of a variable is done at runtime. It makes it very easy to write. It makes you write very simple, concise code, and that's one of Python is also object-oriented, and so it allows you to do a lot of abstraction, own specific objects for your own use case. It allows inheritance, polymorphism, all this stuff. Don't worry about it. We're going to get into what this is at the relevant points of this course. I just know that these are the basic technical aspects of Python. It also comes with an extensive standard library. So you have libraries for networking, data structures, databases that just come shipped in whenever you install Python on your computer. Now I want to talk about different aspects of Python and what you can do with it. You can do a lot of machine learning. So you have Pandas, the Pandas library. You have scikit-learn for training machine learning models. These are libraries that are almost the industry standard, when it comes to anything machine learning with Python, just because Python is easy to write. There's a lot of experimentation that you can do with Python code, and that's the beautiful thing that makes Python the standard language for machine learning. For deep learning in Python, that's when you want to create your AI models like Keras, TensorFlow, PyTorch. So you want to do computer vision tasks, you want to do natural language processing, different things like that. And when you want to build your own web apps, you can build your web apps using different libraries in Python. There are several. Django just happens to be more of the commonly known web frameworks. So if you want to do the back end of your web app, because every web app, you can think of it as having a front end, which is what you see, and then the back end that processes the data. So libraries like Flask and Django allow you to write your web framework or your web app in a very simple and approachable way, all using Python. You can also use Python for data management. Say you want to create your REST. Python has its own libraries that allow you to do that. In the previous slide, we spoke about using Python for the backend of your web application. Python also has the ability, and it has different libraries that you can use to build the face of your web application, so the front end of your web application. Things like Streamlit, things like Plotly Dash, things like UI, libraries like Solara, Shiny. These are all amazing libraries that you can use to build your own different front-end application using just pure Python code. So with all those libraries I mentioned, you don't need to touch HTML, you don't need to touch CSS, you don't need to touch JavaScript, and you're going to have a beautiful, usable front end all written in Python code. There are several libraries that perform mobile app development using Python. The more popular one is Kivy, but there are several of them. There's Flet, would allow you to write your Python code to create an Android app or an iOS app. This just adds to the versatility of the Python programming language and what you can do with it. You can use Python to extract data from different websites. For example, let's say you go to Amazon, you can actually write your Python code that is going to go to Amazon, go through all the pages in an Amazon, extract the title, the price of the products, and even extract the pictures. All of that is possible with web scraping using just your pure Python code. There are several libraries that Happy, you have Selenium, you have requests. There's so many libraries that allow you to do web scraping of any website. If there's a website that exists, trust me, you can write Python code to get all the information on any website. It's really powerful. Any website you can think about, with a few lines of code, you can programmatically visit the website and get all the data from the website. Makes it very. Of course, it won't be any fun if we can't make games with Python. There are several libraries out there that allow you to make different types of games with Python. The more common one is Pygame. It allows you to make two-dimensional games. So, for example, like your Snake and all these other shooter games in pure Python code. It's actually really cool and really interesting to see. This just shows how versatile Python is as a programming language. You can use Python to create desktop applications. Several libraries for this as well. In fact, one of the libraries is Tkinter. That comes standard with Python. It's like Qt that makes beautiful desktop applications that you can run on your computer, whether it's Windows, a Mac, or a Linux. With all of that, you can do it with your pure Python code. Ability, ease of use. It's very easy for you to create just about anything. Anything that can be created in Python. It's so easy, so approachable. And this even goes beyond just regular programming. There are artists, there are musicians that have a little understanding of Python and they go over a specific task. You have engineers that use Python for their day-to-day work. You have accountants, you name it. And this is just because Python is fast enough and versatile enough to carry out in this course, because in this course, I'm going to take you from not knowing any Python to being very productive in the Python programming language. I'm so excited to show you how it's going to be done. I'll see you in the next video where we start to do some awesome stuff. Thank you. We're going to talk about and why it's important. I will talk about the different charts that exist in data visualization and when you might want to use what. Data visualization is a technique used to represent information. Said that a picture is worth 1,000 words, and that is why data visualization is very important. It allows us to summarize complex data information into a few charts. I will go into some of those charts here. Whenever you want to pick a visualization chart, there are several things you need to consider. The very first thing is type. So do you have categorical data? Do you have numeric data? Do you have temporal data? Do you have continuous data? To determine what kind of visual you can use. The next important thing is, what is the goal of your visualization? Are you trying to compare two features or parameters together or physical quantities together? Do you want to show a trend? Do you want to show distribution? When you ask yourself that question, you can start to decide what charts will be most appropriate. Another important thing you need to ask yourself is, what is the audience? Are these technical people? Is it the general public? Are they non-technical people? There are some charts that are very easy to understand that most people are familiar with. So for me, whenever I'm making any visual, I like to use very simple charts that it's so simple for people to understand. So those are essential charts. Now there are several charts you can use, but I like to use the basics because you never know where your presentation is going to go. You might meet a technical person that understands technical charts. You might meet a regular person in the general public that. Here are some of the most essential chart types. You have your compare value across different categories. You have your pie chart, which is used to display proportions of a whole. You have your line chart, which helps to show how a trend changes over time. You have your scatter plots, which essentially just shows the relationship between two or more features. An extension to a scatter chart is a bubble chart where instead of all points being the same size, you can vary the size of it. Then you have your violin and your box plots, which are quite similar, but what they do is they help to show the spread of your continuous numeric data across different categories. You have your histogram, which shows the distribution of a continuous variable, and you show the intensity of a particular variable with colors. So whether correlation between different features or whatever it is, heat maps are also very important. Also importantly, geographical visualization. So how a physical quantity varies across different geographical regions. Whenever you want to visualize data of that type, you Choropleth chart or a chart that shows the map and shows different points, more like what some people call a point map chart or a scatter map box chart. In Plotly Express, which is the visualization tool we're going to use, it's called a scatter map box chart. Now, I want to talk about when you're going to use the different charts. Scatter plots are used to show the relationship between two continuous variables. It can help to reveal if there's a trend, if there are clusters, if there are outliers. So it's actually very important and very widespread in its use. An example of when you'd use a scatter plot is maybe you want to show the relationship between the temperature of a city and ice cream sales. So that's an example of when you can use a scatter plot. Showing the distribution of a single continuous variable. Say, for example, you have students in a class or students in a school and you want to just show a distribution of their ages. A histogram is perfect for this use case. Pie charts are used to show the proportion of a particular category in the entire dataset, especially if the number of unique values in that category is somehow less than 5. Ideally, you want it to be less than 3 or maybe around 3, then pie chart would be a good use case. Most times, whatever you can represent with a pie chart, you can find represented with a bar chart as well. Bar charts are used for showing the relationship between a continuous variable across different categories. So say, for example, you want to show the sales across different regions, a bar chart can be very useful. Plots are very good when it comes to showing the distribution of a single continuous variable across different categories. You can use it for detecting outliers. You can use it for showing the summary statistics. It's actually very useful and is one of my favorite visualization charts, especially when I have a continuous variable and a categorical variable that I want to show together. A violin chart is very similar to a box plot. You can think of it kind of like a combination of a box plot and a histogram. Some people find it more visually appealing than a box plot. And so at the end of the day, whatever you can show with a box plot, you can show with a violin plot. In my experience, I feel like box plots are a little more straightforward because most people are familiar with them. Violin plots, you might need to explain it a little bit before you start using it. The audience and what they are used to, but violin plots are also a very good chart type. If you have any quantity that changes across different geographical locations, then you might want to use a Choropleth chart. Choropleth charts have been used to show election results across different counties in the US. So whenever you see those charts that show the map and then show different colors, that is essentially a Choropleth chart. Line charts are very useful in showing the trend over time. Say, for example, you want to show the price of a commodity, maybe Bitcoin, as it changes over time, then you would definitely want to use a line chart. You can use it to show other physical quantities as they change over a measurement of a continuous variable that has a temporal nature to it, then a line chart can be very alternative to a line chart could be an area chart. They're very similar. You can use them to show the same information. It's much more popular than an area chart. Sometimes you might want to visualize data that has a certain flow to it and a hierarchy to it. Say, for example, web traffic or lead source. Maybe you want to show a dashboard about how leads come to get to find a product. And you know they first start from a certain level and then they trickle down to another level. You might want to look at a SunBuss chart or a tree map chart. Now what you have in this image is an example of a SunBuss chart, and it's a very interesting visualization type. As long as you use it for the right use case, then it can be very useful and very beautiful to look at. So in summary, part of any data project because it gives you the ability to summarize important information and charts. We know that a picture is worth 1,000 words, and so because of that, data visualization is a key step in any process. Thank you for watching. We do some cool stuff. In this video, we're going to install Python. So visit python.org, go to the download section, click on the version 3.13. Once the download is complete, you can open the setup wizard. You need to add Python to path, very important. And you also want to use admin privileges. And then you click on install now on a Windows system. Here we're installing it. Depending on your computer, it might take a little longer, it might take a little less. So let's just wait for this part to complete. And there you have it. Setup was successful. So you can close this and you've successfully installed Python on a Windows computer. Thank you. In this video, we're going to install PyCharm. So the first thing is to go to Google and search for PyCharm Community Edition. There's the Pro plan for PyCharm as of right now, but we don't necessarily need that. If you want it, you can go for it. But we're going to go for the Community Free Edition. Always good. Let's click on the first link and it brings up this page. You'll see that if you scroll down, we can find PyCharm Community Edition. And since I'm on a Windows computer right now, I can click on download and process. Once the download process is complete, we're just going to open the file, install it like you would any other application. So that's what we're doing here. You click next. This default location is fine. So we'll go to the next step. And you want to make sure you check all these boxes to path and select all this. And yeah, we click on install. And once we're done, we finish. And we've successfully installed PyCharm on Windows. Thank you, and I'll see you in another video. For us to download Python, we need to go to python.org. That's the. Now there are lots of links here. You can look at the documentation. What we really want is the section. In the download section, you can pick the Python version, which is 3.13 as at the time of this recording. And now the download has started. So if we click on the download, if we open it, we can start the installation on the Mac. We have for Python on Mac. You just click on continue, agree to all the licenses, check that you have enough space on your hard drive. It's probably going to ask you to log back into your computer to authorize the installation, and we should be good. We successfully installed Python on the Mac. Next, we want to install PyCharm, which is the code editor I use most of the time. The PyCharm Community Edition, that's what we're going to get. There's a professional edition, is the community one that is free that we want. I'll click on download. So this might take a while. We just have to wait for it to finish. Once it's done downloading, we push it into the application folder and we should be good to go. So when you're ready to launch PyCharm, you just go to the Finder, and this is what PyCharm looks like. You can click on a new project, give it a name that you want, and this is what inside the code editor looks like. You have your terminal, you have access to your GitHub repository from inside the code editor, but don't worry about what a GitHub repository is right now. You can create new files, so new Python files, new text files, HTML files, it can all be done. Now if you run this code and it prints out this output from the terminal, then you know that everything worked fine in terms of the installation of Python and PyCharm. In this video, I'm going to show you how to open PyCharm. So we go here. I'm on a Mac Mini. So just give it some time to come up. It's coming up now. Now, the way your PyCharm might look could change over time, but there'll usually be a place where you can say new project, or you open an existing project. Let's just say new project. You could also get projects from the GitHub repository, but we're not going to worry about that right now. Click on New Project. Whenever you do that, PyCharm tries to help you with this, where it allows you to set up a project. You give it a project name. So let's just say Learn. You can name it anything you want. One of the advantages of PyCharm is it allows you to create a new virtual environment whenever you're creating a project. If it says new environment, and you can give your environment a name, and that's pretty much it. You click on create and we should be good to go. This is us opening PyCharm for the first time. It's going to create your environment. Most times when you just open PyCharm for the first time that day, it's going to show you tip of the day. You can close it or you can look at it if you want. I just want to walk you through what the environment looks like here. We have our terminal. If you press this button. Now this is what your PyCharm will look like typically. If you come here to terminal, you'd see everything here. You see the name of the project, its location, and you can do a lot of cool stuff in terminal. If you want more terminal windows, you just click on the plus button. Now in your system, it might look different. It might not be dark mode, it might be light mode. There might be small variations here and there, but generally the format should look pretty much the same if we're both using PyCharm. When we created the project, it created all these extra files. I'm not going to worry about it. I just want to show you that you have virtual environments here. Your version number for PyCharm and Python could be different, and it could show the difference there. Now, if you want to create a new file, you could right click over here, say new. You can create a new file. Let's just say, let's create a text file. I call this hello.txt. If we right click with our mouse, go to new, you could also create a new Python file. We could just call it anything we want. Let's say hello, and it creates the new Python file here. You could also just click on, let's see that. Let's just call it hello as well. We're not going to be going to show you that there are different file types you can use while working in PyCharm. You can also come and create a new directory. You can create a new Python package. Let's say new directory. We'll just give it a name, new directory. You can also create new Python packages. If you don't know what a Python package is, don't worry about it. I wouldn't stress about it, but I can show you how to create a new Python package. We'll just come here and say hello, and we see that we have a new Python package. It's very similar to a directory. Only difference is it has this special Python file underscore init underscore.py. So that's what makes it a package. Very special. We're not going to worry about that right now. Now, if you want to close this directory folder area, you can easily do this. Not a problem. And you have way more space to type your code. Now let's just type a very simple code here. Let's type our hello world and just say print. So we have a very simple Python command here. Just say print hello. If you want to run this file, there are several ways you could do it. The easiest way, you could just right click. In PyCharm, most code editors have this feature as well, and just click on run. Let's see, once you do that, once you're able to execute that, it comes over here. We see the output just comes here, and that's good. Another option could be, you could go to directory. In this case, we are in this directory. So you're going to call Python, and you're going to call the name of the file. In this case, it's hello.py. And once you press enter, it does the same thing. So these are the two ways where you can easily run a Python code. If you're able to run this code without any errors, then it just shows that your installation of PyCharm was successful and we have nothing to worry about. I'm on the Mac Mini. If we come here, we see we have options for settings. We have options for different things. We probably won't use a lot of them right now. I just want to show you this area. You can change the editor if you want to change anything here. Maybe you want the font to be bigger, smaller. You want to change the appearance. There are different themes here as well. You can change it to a different theme if you really want to. Personally, I don't want to use this because it's just too bright and I feel like I'm gonna get a headache if I keep looking at it too long. But if you prefer this light appearance, then that's totally fine. We have different options there as well. You see there's a slight change. We have this, and you also have this. Okay, if you want it to look like this, you can. So there are different options for customization in PyCharm. I like the default one, so that's just what I'm going to stick with. In this video, we've learned quite a bit. We're able to open up PyCharm, create a new Python file, create a new HTML file, create a new text file. I was able to show you how to create a new directory by right-clicking here and selecting different things here. So that's good. I was able to also introduce you to the terminal and how you can conveniently run a Python program. And yeah, thank you for watching. I look forward to seeing other videos in this course where we learn some awesome stuff. Thank you. In this video, I'm going to show you how to install Python libraries. I'm using my PyCharm code editor here. In PyCharm, all I have to do is to go on the version of PyCharm you have. Future versions, it might be a different place. In other versions of PyCharm, it might be on this side. In this version of PyCharm, it's right here. Whatever you want to do, you want to get to the terminal. And you type in certain commands. It's going to be pip install, let's say, for example, pandas. So that says the requirement has already been satisfied. Great. I could do pip install plot. What I just did was just different Python. So that's essentially what you're going to do. This is how you're going to install libraries. You use the pip install and then the library name. For every library I'm going to use, I'm going to have a lecture that will have the exact command that you should run from your terminal. This video shows you how to run from your terminal. Thank you for watching, and I'll see you in another video. Since this course is about data visualization, I figured that the Hello World example should show that. The first thing we're going to do is create a new file in our directory and just call it hello. Now, because I want us to demonstrate one of the libraries which we are going to use, we're going to have to install that library. I have my terminal open over here. I'm going to run the command pip install plotly. Now that I have the command pip install plotly, I just need to press enter on my computer and it should proceed. In my case, previously, it shows that the requirement has already been satisfied. So that's fine. This is what the directory looks like. I can close it. We have our hello.py file open there. If I were going to use a file with my code, you'd want that file to also be in the same directory as your code to avoid all types of problems. In other courses, the Hello World example is a toy example. In this one, we're going to go into the deep end where I introduce the key concepts you need to make visuals in Python. Explain everything in depth in future videos, but I wanted to just give you a taste of what it's like to create visuals in Python and how easy it is. The first thing we're going to do is import the library we're going to use. For this, we're going to use the Plotly Express module within Plotly. Then we're going to create 3 other variables. I'll call this xlist, and then we're going to create another variable called ylist and just put some random numbers there. Then we're going to create another variable for the title. You can call it whatever we want. And this is a string, this is a list, this is another list. Then we're going to create another variable to hold the graph object. You can call it plot. Then we'll use px, import the scatter function from Plotly Express. And in this case, we have our data in an X list and a Y list. We don't need to specify data frame or anything complicated. We're just going to specify what our X is and what our Y will be. I will specify the title, and that's pretty much it. So X is going to be X list. Y is what we want on the Y axis. I want to be Y list. Title. And next we call the show method. Now, if anything we've talked about here is a little confusing or sounds strange, don't worry about it. I will explain everything here in future videos in a very great detail. I just wanted you to have a taste of what it's like to create a plot in the Plotly library, and that's why we have this. We've typed the whole code, it's less than 10, more like 7 if you exclude the spaces, and you can right click and go to run, and we're going to see something pop up. Now we've successfully created our plot. You see that we have the title here, Hello World, with a whole bunch of unnecessary exclamation points. We have our x-axis, we have our y-axis. You'd see that the points are interactive, so I can zoom in, I can move my mouse over the points, and we see some printouts. This is really cool. And just let's go back to the code and do some awesome stuff. There you have it. In less than 10 lines of code, you've successfully created your visual. The visuals we're going to create in this course is going to be several steps ahead of this. I just felt like this is a good introduction to the course, and it sets the tone for why you're learning what you're going to learn in the future videos. Thank you so much for watching. I'm truly excited that you decided to take this course. I'll see you inside. Thank you. In this video, we're going to talk about variables. Variables are the fundamental building block of any program. They are the way we store data in the computer's memory, and that's why we need to talk about it in this video. Variables hold data of different types in your program. Remember when we said programming is just a way to model the real world? And in the real world, you have data, you have different kind of information. The variable is just a way where we keep that information or that data in a computer's memory. You can use a variable to store different data types. For example, your numbers, what is your age, how much is your bank account, what is your height, numbers like that. You can also use a variable to store text or Boolean values. Boolean values refer to true or false values. Variables allow programs to remember and use data dynamically. Python programming language is a dynamically typed programming language. And what that means is it allows you to define a variable of a specific type. And during the execution of the code, you can go to another part of the program and change the value from when it was a number, still using the same variable, and change it to a string. Now, other programming languages are a little more strict on your variable type definition. Whenever we define a variable in programming, it's stored on the computer memory. You can think of the computer memory just like your human brain memory, so they are quite similar in different aspects. In the human memory, you have a short-term memory where you hold immediate thoughts and current tasks. It's not stuff you keep for a long time. In the computer memory, that short-term storage is in the RAM. It's called random access memory. So that's just where you hold data that the computer is currently using right now to execute its current tasks. Whenever we talk about computer memory, all you just need to know is that in any programming language, it is stored in the computer memory. So that whenever your programming code needs that variable, it just goes, looks at the specific part of the memory. Like I've said previously, whenever you declare a variable, the computer allocates a specific memory address to store the variable's data. So let's say you create a variable representing your age. That value of your age is stored specifically at a particular address on the computer. Variables have different types. So you have integers, which are numbers, you have string, and you have Boolean, whether it's true or false. The data type of a variable tells the computer how to store and interpret the value. In Python programming language, the computer dynamically stores and manages the memory for the variables. Now, this is not the case for some other languages, and this is just part of what makes Python programming very much approachable when it comes to comparing to other more complicated languages where you, the developer, are responsible for actually managing the memory. This is purely just for information. We're not managing our own memory in Python, and that's awesome. As you go on your programming journey, if you see the need to learn more lower level languages, like maybe C or C++, you can definitely do that. But I believe Python is a very good starter language because with you just learning Python, you're able to do some amazing stuff with it. And that's what this course is all about. What we have here are just 3 variables that were created to store 3 different types of data in 3 different variables. So you have your integer, the age variable stores the value of 30 with the equal sign. You have the string, say Alice, someone's name called Alice. We're storing the value of Alice as a string into the variable called name. And the other one, you have a boolean. A boolean is just a fancy way of saying true or false. So we have the variable called isStudent, and it can take a value of either true or false. So what we have here are just the 3 types of variables, the more primitive variable types that you can have in Python. Whenever you're talking about variables in Python, there are certain naming conventions. The first one is you want to use descriptive names. Now, this is more of an advice for you because I've written code before where maybe I didn't put enough comments or I didn't use descriptive names. After 2 months, I came back to the code and I didn't know what my code was doing. It's also a good idea to use a snake case whenever you are creating your variable names. Snake case is just a fancy way of saying if you have 2 words that form a variable name, separate them by an underscore. And then thirdly, you want to avoid reserved words. Now, Python programming has certain reserved words that have already been used by the program. And if you try to use it, it's going to cause some conflict. So you want to always avoid using reserved words. And in this next slide, I'm going to show you some of the reserved words that exist. Now, these are some of the reserved keywords in Python. You cannot use any of these words. F, you can't use that as a variable. You can't use any of these words. These are reserved words. But any other word that you can come up with is fair game when it comes to creating a variable name in Python. You can start a variable name with a letter or an underscore. So you can never start a variable name with a number. It's going to be an invalid variable. Variable names in Python are case sensitive, and in every other programming language, by the way. For example, you see here we have name with a small n, you have name with a big N, and then you have name with all capital. These 3, to you, it means the same thing, right? It's a name, right? We all know what name means. But to a computer program, all 3 names are different variables. Now, you have to be very careful whenever you do this because this, for me, I've seen is a cause of a lot of errors for beginners when they write code, is forgetting that their variable names are case sensitive. The good thing is if you use a good development environment, an IDE, just a place where you write your fancy code, most IDEs are able to help you whenever you are making any variable name mistakes. It will help you highlight problematic parts of your code, and it can definitely fix it. In Python, whenever you want to assign you want to use the equal sign to do that. And we're going to have a code along section where we get comfortable with creating variables and assigning it. Now we know variables are the building blocks. It's also important to know operators and what an expression is. There are different operators in programming. You have your basic arithmetic, so your addition, subtraction, multiplication, division, raising to a power. Those are some of your arithmetic operations. You have operations that allow you to compare if 2 things are equal to each other, if one is greater than, if the other is less than, if it's greater than or equals to, or less than or equals to. You have your logical operations, that's your AND, your OR, your NOT, and then you have your assignment operations that helps you assign values to a variable. Whenever you have a combination of values, variables, and operators, what you have is an expression. As you write more code, you're going to find yourself creating code expressions, doing your variable assignments. It sounds more complicated than it actually is, but don't worry, I'll show you what all this is in this course. So variables are the building blocks in programming, and in the next few videos, we're going to have code along session where I'm going to walk you through how to assign variables, how to create variables, and how to do some cool stuff. Thank you for watching, and I'll see you in the other videos. Hello. In this video, we're going to look at some basic arithmetic and how you can do just basic calculation using Python. I just have 2 variables. One is 3 and the other is 90. Here I'm showing you how we just do addition. So this is the sign for addition. And I can create a new variable to show subtraction, multiplication, division. So let's do it. The num4 is going to be Let's just do num2 minus num1, and then we could do the same thing for multiplication and division. So let's do this, just paste it, 5, 6, we can say num2. So this is what you do for division, and then you can do this for multiplication. So this is what we have. We are able to do addition, subtraction, division, multiplication. It's, if you are in PyCharm like me, just right click anywhere in the code editor, go to run, and it's going to run it right there. But I know most people might not be using the same code editor as I am, and so I'll show you how you can run it from the terminal. Now this is my terminal. I'm in the same directory, Python Basics, as my code. So if I show you my directory here, Python Basics, this is basic arithmetic. So that's what the directory looks like right now. Let's assume you're in the right place. To run any code, you just say Python basic_arithmetic.py. So Python space, name of the file. The file in this case is basic arithmetic. And that's how you're going to be able to run any file from the terminal in Python. So but most modern code editors, you don't need to worry too much about all of this. Once you click here, you can run it. But I just want to show you how to run it in another way anyways. So let's run it this way. Now we see the addition here, this is what we have, 90 plus 3, that's 93. Subtraction, N2 is 90 minus 3, that's 87. Division, 90 divided by 3, that's 30. And then multiplication is this, with the asterisk, that's 270. Of course, we can do other things as well, say squared, square root, exponential. So let me show you what those look like. So if I want to show square or raise to the power, what we call exponential, that's going to be num1. Let's say we want to do num1. When you put double asterisks, you're telling it that you want to raise it to the power. So let's say this is going to be num1 raised to power. And we know num1 here is 3. So 3 times 3, which is 3 squared, is going to be 9. So let's run this. We go to the terminal. Python basic_arithmetic.py, and it shows us 9. Okay, what if I wanted to get the square root? Square root can be done this way, but instead of it to be 0.5. For square roots, let me change this to a variable we don't have yet. So let's just call it num7. And I could come here and just do num is equals to 16. Now if we say num7 raised by 0.5, we know that whenever you raise something to the power of 0.5, you're essentially just saying, give me the square root of that number. That's just like a math thing. But the whole point is for you to just know that whenever you want to raise power, you're going to use the asterisk, but 2 of it, okay? So this should give us 4, because the square root of 16 is 4, and num7 is 16. So let's run this. Yep, square root is 4. Now, sometimes you might want to make a kind of division. Let's come here and just do num8. You want to divide a number by another number and see what the remainder is. Say, for example, if you divide 16 by 3, you might want to know what the remainder is. So let's look at how you can do that here. So let's say num7, which is 16 in this case. Then you do num1, and we print 8. Let's see what we get here. You see, that's 1. This is how you get the remainder. This operator is used to find the remainder, because when you divide 16 divided by 3, you get 5, and then what's left is 1, because 3 times 5 is 15, and then the remainder is 1. So this is how you get the remainder. We've looked at addition, subtraction, division, multiplication, how you get the remainder, and we looked at how you can raise to the power. So yeah, in this video, we've learned how you can do some of the basic operations like arithmetic operations, addition, subtraction, division, multiplication. These are just things you can find yourself using in your code sometimes. So it's good to know how to achieve it using just Python. And we looked at the different cases. We're able to print some of the output out. And yeah, thank you for watching. And I'll see you in another video where we do other cool stuff. In this lecture, we're going to talk about Python strings. And strings are a fundamental data type used to represent text. This presentation will delve into the core concepts, methods for effectively working with strings in Python. A string in Python are sequences of characters enclosed in either single, double, or triple quotes. They are immutable. That means that their content cannot be directly modified. You can create strings by using the single quotes, double quotes, triple quotes, whatever you get is going to be a string. You could use functions like the str. With strings, you can a string using your square brackets and your start and stop position. You can add strings together. You can repeat a sequence of string by using the multiplication sign. And you can also check for character membership in a string. So for example, let's say you have a string for the word apple. You can use your Python code to check if P exists in that string, A exists, or L exists. It's very simple to do. And in the code along section, I'm going to show you how to do different operations in strings. Python strings has about 47 built-in methods. Now, we're not going to look at everything this week because I want to make sure that whatever we are learning is focused. But before the end of this course, we will go through every single string method in Python. So don't worry about it. We're going to be thorough in how we cover the string methods. But for this week, we'll probably look at just a few of them. The most important ones that you're likely to use is what we're going to cover. Now, if you had to get familiar with 10 string methods, I'd say these are the most important string methods that would be good for you to know. The first one is upper, where you use it to just convert all the characters in a string to uppercase. You have lower, you have strip, you have split, replace, starts with, ends with, join, count, find. If all this sounds very alien to you, don't worry about it. We're going to have a code along section where we go into some of these methods. Now, because text is a very important data type in the world, we have a lot of use cases for strings in Python. So when you talk about things like web scraping, which is essentially just using your Python code to visit websites and extract information from those websites, you have data parsing, you have text analysis, and you have file handling. These are just some practical use cases for strings, but of course, there's so much you can do with strings, and that's why it is a very important data type in Python. Thank you for watching, and I'll see you in other videos where we do some cool stuff. In this video, we're going to look at 10 of the most commonly used string methods in Python. So let's start with a sample text. You can just say text, let's say hello world. So this is our string here. You see that we have our single quotes and we have a word in there, we have space, we have everything. As long as it's wrapped in the quotes, everything is fine. Next, we want to just look at the type of this data. So you say print type text. Now if we run this, you see here that it's class string. Of course, we already knew that. Now we can check the length of this string using the len function. So if we run this, we'll see what it is. And we see that there are 11 characters in this string. Hello is 5, world is 5, that's 10. And then this space is also a character as well. Okay, let's look at the next method. So let's use the lower method. And we can say, let's print text.lower. If you run this, we see here that we have the lower form of the text. The H, capital H is turned to small h, and the capital W is turned to small w. Okay, we can do something else here. So let's just say lower. Let's add a comment. We can do the same thing, but instead we change everything to uppercase. What you see is we have the same text, but this time everything is upper. So not lowercase, it's now all uppercase. Okay, let's look at another method. Let's look at the strip method. Let's just create a new text. Say new text. We can use double quotes this time just to demonstrate. Hello text with spaces. You notice we have spaces on both sides. There's space here, there's space here. Okay, let's see what we get if we run the strip method. So let me put this here. Let's run this and see what we get. So essentially what it does is it removes this space and this space. So we no longer have those spaces. It might not be very easy for you to see just because, you can't tell if the spaces are there or not, but that's what the strip function does. It removes the space on the beginning and at the end. Now this can be useful if you're trying to format your data. You're trying to format your data and you don't want those white spaces that sometimes occur in the beginning of a string. And you don't want the white spaces at the end as well. So let's use the replace method here to carry out some magic. Let's first put our print statement, and we want to replace world with Python. Let's do this. So we can say, let's just label this first, replaced We can put a comma so we can print something else, and we'll start with text. Let's replace something else. We could say replace this with Python. Of course, you can replace it with whatever you want, but this is just an example. Now, if we run this, let's see what the outcome is going to be. We see replaced, hello Python. So before we do that, let's print the old stuff just so you can compare. So let's say print old string, and that's text. So let's replace that. Let's run this so that we can see the difference. So the old string is hello world, and after calling the replace Python, you get hello Python. Now this is all well and good. I can show you another example of how replace is used most commonly. You can use it to just remove spaces. So in this example where we had new text, we have a bunch of spaces. Now this is an operation that is actually done quite a bit of time. So let me just show you. You can do this, new text. Now you want to replace the space with no space. It's like a pro tip that I'm about to show you. That's it, you see? Okay, maybe I should show the old text as well, just so you see it. Let's come here and see. Text, new text, yeah. Okay, let's do this. And yeah, you see hello text with spaces, and we replace it by using the replace function. We replace all the space with no space. So while you're reading code that exists, you might see something like this and you might be asking yourself, okay, what is this doing again? Essentially, we're just saying Python, go to everywhere where you have this one space character and replace it with no space. And so that's what we have here. Very cool stuff. All right, we're going to use the split method here. Let's go split. So we have our string here. You'd notice I use triple quotes. I've used double quotes previously, and I've also used single quotes. These are just different ways which you can use to create your strings. So we have this. With the split function, we can split this up based on a given character. Let me show you what I mean by that. Say split, put a comma so I can print something else. So I'm just going to call fruits dot. So I'm going to pass in the character that I want this to be split on. Let's say I want to split on the comma. I'm just going to pass this in, comma. And yeah, let's see what we get. So let's run this. Now you see that what we have is every single thing in this string is broken down into lists. Let me show you something really quick just so you can see what it is that we have here. Type of this, you see that the output of the split method on a string is going to give you a list. And if you think about it, it actually makes sense, right? You have one big string, you want to split it. It makes sense for it to become a list. And we split it based on the comma. What if instead I want to split it based on the letter A? What do you think is going to happen if we do that? Well, it's just one way to find out. Let's do this. And you see how interesting it's going to be. Split on A. So instead of the comma, I'm going to put this in here. A, you see? So what this does is wherever we have A, it breaks it up that way. So between this A and this A, it just grabs this. So it goes between this first A and this second A, and it just gives PPLE, comma B. That's what we have here. Then the next is this. This N is between both A's, so it just returns the N. This other N, it returns it. And then for this one, between this A and this A, you have this G. So that's where it returns. And between this A and this A, you have just the V. That's what it is. And for between this A and this A, you have the S. You can actually use this to split based on any character. Doesn't matter. But you're more likely to find this being used in code. So if you see this, just understand that we're essentially converting this string to a list. That's it. That's all we're doing. Of course, breaking it down based on a specified character, and then we're going to get a list as the output. Pretty cool stuff. Let's look at another example. So to demonstrate how the join method works, we're going to start with a list. Let's just say fruits, but I don't want to overwrite what we already have. So I'm going to do this. And I could just say apple. Okay, so we have these fruits. Now you might ask yourself, well, if we have a list, how is this a string method? So I'll show you how it's a string method. You have your comma here, and we're saying, okay, this is the string we're working on. So the method we're going to use on this string is the join method. The join, I want to join everything in this list, fruits underscore. Let's see what we get. You see, what we have is just this. If we check the type of this output, let's say type print type, we'll see what we get here. I see that it is a string. So it's a string method because we work on this string, but we specify what we want to join the elements of this string together. And that is, we want this string to go into this list and just join everything based on this. Now, if we remove this space character that we have, we're going to have a different outcome. Notice that there is a space here, there is a space here as well. If we run this, it's going to be different. You notice that there is no longer any space. This is how you can use the join. It's actually a very commonly used string method, so it's very good for you to know how it works. Let's try something else. Let's say we want to join on using a instead of a comma. So let's do this. So we're saying, okay, this string letter A, let's see what it's going to become. And you see what joins every element of this list is the A. You see the A, orange, we see another A here. This is how you could use the join method. We could even replace it with colon if we wanted to. So the way to think of this join method as it acts on provide in this string is the glue that merges every element of this list together. So the join method is so useful. You're going to come across it for sure. As you read code that is in production, as you write more code, you will come across this. That's fine. Let's look at some other methods in string as well. The find method helps us to search through a string and gives us a response if we find a part of a string that we're looking for. So we know we are starting with text, and this is what we defined up here for text, hello world. Great. So let's check if we're going to find Python in there, or if we're going to find Java, or if we're going to find hello. Let me just do this here. Let's say hello. Okay, so let's see the outcome. So let's print our original text here first. So let's run this. Now you'd find that in this original text, we have just hello world. That's what we have. So there's no Python in there, there's no Java in there, but there is hello. What the find does is if something is present, it's going to give you the position of where that substring is. Now this substring is located at the first position, but because we don't have Java or Python in here, it just returned -1. Okay, let's try to find world in there and see what we get. So instead of hello, we'll say world. Okay, let's run this. Now in this case, what you find is that when we search for the word world or the substring world, you see that it is at position 6. And of course, if we count it, that is the case. So this is 0, 1, 2, 3, 4, 5. Then the W is at index position 6. And this is how it works. If you get a negative, it just means that whatever you were searching for using this is good. It's actually very useful, extremely useful method. And this is why this is one of the examples I'm choosing to show first. Another one is the starts with method. This is good because it helps us to know if we're starting with a substring or a character. So we know what our text is. We can also print it again if we like. Let's print it here, print it. And we have this. Let's run this and see what we get. We see that what we want is we're checking this text, hello world, and we say, okay, does hello world start with hello? The outcome of this is true. Then we say, okay, does hello world start with Python? The outcome is false. And this is what the starts with does. Of course, if you're going to have starts with, then you're probably going to have the next method, which is ends with. And of course, you're right. We do have ends with. Let's see what ends with can do for us. So ends with, can you take a guess on what this would do? Can you take a guess? Okay, let's change this to world. Change this to world as well. Okay, let's run this and see what we get. Okay. Can print it. Now see, indeed, it does end with world, the substring world, and so it returns a true. It does not end with hello, so that returns a false. We can try another variation and just see if it returns or if it ends with a D. Let's do that. Ends with a D. Let's see what we get. Let's run this. And of course, it ends with a D. Okay, so we can bring this to an end. We've looked at the 10 most commonly used string methods. We have The type len, we didn't count this as part of the 10 because the type is just a Python object method. Len is also common to every other Python object. We started with lower, which changes your string into all lowercase. Then we move to upper, we move to strip, which just removes any beginning and ending space. We looked at replace, which replaces a substring or a character in your string with something else. Look at split, which converts your string into a list by splitting it based on something, a character that you specify. We looked at the join method, which works on a string, but also needs a list or a sequence object in addition to the string for you to be able to do something cool. We looked at several variations of that. Join is very important. We looked at the find method, and we looked at starts with and ends with. Like we said already, we have 47 string methods, several of them, but I don't want to just bore you with all 47 at once. That's why I chose to look at this top 10 first, and then over time, we can take a look at the others. Thank you for watching, and I'll see you in other videos in this course. In this video, we're going to talk about the lists data structure in Python and what you can use it for. For us to fully understand it, we're going to use the example of a shopping list to get to understand what the list data structure can be used for, and it's going to be a very good one. A list is a very special data structure in Python. You can use it to store different data points, so whether strings, numbers, and you can put them all together. Think of it like you're putting it in one special box. A list in Python is very similar to your shopping list. You know, whenever you go shopping, you create this list of items. And because we know that programming is just another way of telling a computer what to do, it means we need to be able to represent real items. For example, a list of items you want to buy or a list of friends. We need to be able to represent that as a data structure that a computer can understand, and that's why lists are important. Just like when you go to the shopping mall, you might want to go buy grocery items, you might want to buy a car tire at the same store if it's one of those, big stores that you can buy groceries, you can buy car parts, you can buy electronics. A list is also able to hold different types of data all in one container. Of course, whenever you have a list, add stuff to your list. When it's just pen and paper, you just take your pen, give it a number, write what you want to write, and that's you add into the list. But when you want to do it in code, there are special methods that allow you to be able to add items to a list. One of them, which you are very likely to use a lot of, is the append method in Python lists. This is how it works. Just as it's important to be able to add things to a list, it's also important for you to be able to remove items from the list. In the real world, all you just got to do is take your pen, scratch off anything you don't want, or erase it if you wrote it with a pencil. In case of a programming list, you can use the del keyword, you can use the remove, you can use the pop. They all remove items from the list, but they also do different things as well. The method you use depends on your use case and what you are trying to achieve. So it's pretty cool that we have all these options for removing items from a list. Now, depending on how long your list is, you might need to start searching for stuff in your list. You can find items in your list. You can use the in operator, as you see on the index method, and all of this will be shown in the actual code along session that has to do with Python lists. Counting items on a list is very important. Sometimes you might go to the store and buy a whole bunch of shoes and find out that you got too many shoes and you want to return some. Maybe you can only have 3 shoes, but you ended up getting 10. Well, first you need to count how many shoes you bought in your shopping cart to know if you need to return 7 and be left with only 3 shoes. Because something like that is such an important operation, Python lists come with the method for counting, and we can see it in use here. We will have a code where we can actually get into it and see how it works in real life. Python lists come with a sort method that allows you to sort your list and arrange it in the proper order. For example, here we have a list variable toys with truck, beer, ball, and doll. After you call the sort method on it, it's going to arrange every item in that list alphabetical, starting from ball and ending with truck. This can be important if you have a shopping list as well, or you have maybe a list of friends. You are going through your phone book, but you want to get to a friend whose name starts with a Z. You know that's going to be towards the bottom. And so the sort function comes in very handy whenever you're trying to manipulate a list. You're trying to get to some items in the list much quicker. The copy method allows us to make a copy of your list. There are several scenarios where you might want to do this. For example, if you want to carry out an operation on the lists with the elements that you have, but you don't want to change the original, you could make a copy and work on that copy while you keep the original stock as it is. Because such an operation is important, Python lists have the copy method, which allows you to copy a list and have the identical elements in a different list. You have the reverse function, which reverses the order of your list. You have another means of adding items to your list, but this time it's called the extend method, because it essentially just merges two lists together. The extend method is just another way of adding items to a list. The difference between the extend and the append is, in the case of the append, you're going to add one item to the list, but in the case of extend, you're actually adding a list to another list. In this example here, we have my list and we have new list. If you call on the extend method on my list and pass in the new list, what you're going to have is going to be one big list that has all 4 fruits together in one list. Extend can be useful when you don't just want to add elements, but you want to merge 2 lists together. The insert method allows you to add an element to an existing list at a specific position, and the code example we have just shows how that can be done. The methods you see here can be used to clean up your list. So you have declare, you have pop, you have del. This is the different ways you can clean up your list. What you have here are the 11 methods that you can have for a list in Python. In the next video, we're going to go through each and every one of them and get an understanding of how you can work with them right there in code. Thank you for watching, and I'll see you in the next video. In this video, we're going to talk about lists, and we're going to write some code to do some of the common operations you can find in a list. I'm going to create a list of my favorite cities using the square brackets notation. So creating the list here, I'll start with Lagos. This is Lagos in Nigeria. Obviously, I'm going to mention Houston. Let's say I love Austin. Austin is pretty cool because I love Miami, and I love Santa Fe. So these are some of my favorite cities that I've passed in a list. You see that I have them in the square brackets here. We can start by indexing the list. So let's index the list. If I want to print out what's in the first position, my fifth city. We'll see the output here. Element in first position is Lagos because I use 0. So this is position 0, position 1, 2, all the way down. Now, if I want to show the element in the last position, in this case is Santa Fe, I can do it in 2 ways. Come here. And this is one way I can get the elements in the last position. So if I run this, we see elements in the first position is Lagos, elements in the last position is Santa Fe. I know that this is 0, 1, 2, 3, 4. Index position 4. And I know the length of this list is 1, 2, 3, 4, 5. 5. I could easily do this. We calculate the length is length of cities. And for this, what I just need to do is just pass this length and subtract 1 from it. And it's going to give me the same output as this. The reason this works is because we know this is 0, 1, 2, 3, 4. But we know that the length of this list is 1, 2, 3, 4, 5. So 5 minus 1, if you do it like this, will always give you the right index, which is 4 in this case, for you to get the item in the last position. Now, if you don't want to do all of these, you could just do a negative index as well. Let's get the element in the second position. So we can do this, element in second position, and we'll just change this, say second position. So that is Houston, and this is index 0, index 1. So we'll just change this to 1, and let's run this. If I expand this, you see, okay, there's Lagos, second position is Houston, last position is this. This is the basic gist of how you can index your list. We can also select a subset, select subset of lists, and for this, we'll just call on our list, let's say favorite cities. We use our square brackets notation. Let's say I'm interested in just showing what is in index position 1 to the end. Wrap this in a print statement. If we run this, you see that it starts from Houston. So this index 0, this is index 1, all the way to the end. So it shows Houston, Austin, Miami, Santa Fe. This is what we have here. If we're interested in showing it from index 2, that's Austin, all the way to the end, we can do this as well. And we're going to see, when we print this last statement, we're going to see Austin, Miami, Santa Fe. Let's run this. Austin, Miami, Santa Fe. These are different ways you can select a subset of a list. What if I want to make it a little more restrictive? I want to restrict it from the left side and from the right side. Let me show you what I mean by that. Let's say I'm interested in just showing this subset. Let's see what we get. Let's run. And you see we have Houston and Austin. Now you ask yourself, okay, why don't we have Miami? Because this is 0, 1, 2, 3. Whenever we do this kind of indexing in a list, it starts from this position, position 1, which is Houston, position after the colon. So if this is 1, this is 2, this is 3, it's going to exclude position 3, and it's just going to print out Houston and Austin. So this is how the indexing works in Python list. We know that one of the key features of Python lists is the fact that they are mutable, meaning you can easily change some of the items there. And we also know that they are heterogeneous. You can have a list in a list, you can have an integer, you can have a string, all types of stuff in the same data structure. So let's just say my personal data for the say my weight 170 pounds, at least last time I checked. What else can I put here? Okay, I can put country, so USA. Let's say I had a web application and the engineer decided to store my personal data in a data structure, in this case a list. This is what it could look like: my name, my weight, and country where I reside. Let's assume I enjoyed myself too much during Christmas and I put on some pounds. We can change this from 170 to maybe 600 pounds, right? So let's do this. But before we go further, let me just add just a comment here. Name, weight in pounds, country of residence. Okay, this just describes what we have in the list. First, let's find a way to get this value, my weight, out. So I'll just say list, and it's in position 1. So position 1. If we print my weight, this is what it looks like. Let's run this. Oh, let's run this. You see it's 170. Let's say reflect weight again. So let's go change this. Now if we print my personal data, we'll see a difference. Let's run this file, and we can also run this before and after. So before, let's put it here. You see I'm printing my personal data and I'm printing it again. Originally, this is what it is: my first name, my weight, and my country of residence. Then I change what's at index 1, which is my weight, to 600 pounds because Christmas was too good. And if I run this now, this is what it looks like. This is a sign that lists are mutable. There are some other data structures where you would not be able to do this kind of change, but at least has the advantage that you can easily do this. That's perfectly fine, and that's a good thing. We can stop the video right here. We've learned a lot about lists. We learned about how you can create a list. You can index the different elements in the list. We use some built-in functions like print and length. We're able to select subsets of your list, and we're able to also make change to an element in a list. In the next video, we're going to build up on this and still focus on lists, but look at some other features of a list. Thank you, and I'll see you in another video. In this video, we're going to look at different ways in which we can add items to a list. I'm going to create a list of car models. Let's say my favorite cars. This time around, I'm going to use the list keyword to initialize the list. And we can print this. Okay, we run this and see. We see that we have an empty list. Print the length of the list. Don't use the square brackets. You could also use the list keyword to initialize your list. We use append to add items to the list. So my favorite cars, append. And for this, I'll say Porsche 911. So let's print this. If we run, now you'd see that the length of the list is no longer 0, but it's now 1. And when we print the list, we see that we have Porsche 911 in there. Okay, let's say I have a second list. And here I have the E46 3, and I have a Nissan 370Z Nismo edition. And I'm actually a big Nissan fan. Let's say I add a Nissan Frontier and we had a Datsun. So as you can see, we have two lists, my favorite cars, where we just have the Porsche 911 there. And I have a second wish list where I have the BMW E46 M3, Nissan 370Z Nismo, Datsun 2, this should be 280Z, that's the one I want. And I have a Nissan Frontier. This is where we can use the extend function to merge both lists together. And I'll show you how to do it. So we'll have extend my fave cars. Okay. Next, we can just carry out the extend operation. Say my cars.extend, and we pass second list. Now, if we print this after the extend operation, we'll see there's going to be a difference. Let's run this. So, and here we print this list, my fave cars, and this is what we have here because we did an append operation up here, and that's why we have that. Then we also created a second list and we did an extend, and you'd see that it essentially just took the contents of this list and pasted into this list. That's why you have Porsche 911, BMW E46 M3, Nissan 370Z Nismo, and the rest is history. So this is how you can use extend. How about insert? The insert method adds an item at a specific location in your list. So in this example, we have our my favorite cars. I want to insert it at position 1, and I want it to be a car called AMG GT. If we run this, you'd see that this is what we have. Initially, we started the list with this, right? 911 E46 M3. And then after the insert function, I say I want you to insert this text, this object, or this element at index position 1. So this is 0, this is 1. If I want it to be at index position 1, it means it's going to take over this spot. We just insert it there, and then every other thing shifts away. This is how the insert method works with the list. And this is what our final list looks like. 911, AMG GT, BMW E46 M3, Nissan 370Z Nismo. And yeah, we can call it a day with this video. In this video, we learned about the append, insert, and extend. These are 3 different ways you can add items to a list. And we had some good examples looking at just a list of car names. And yeah, we're able to learn everything that has to do with inserting or adding more elements to a list. So looking forward to learning more in this series of lectures. Thank you, and I'll see you in the next video. In this video, we want to learn more about some list methods like index, count, reverse, and sort. Let's start with sort. We see that we have a list of the different states in the US. We see that it's not necessarily arranged in any particular order. Let's just print it out. Let's run this, see what that looks like here. So we have Texas, Georgia, New York, California, Nevada. Now, if we were to sort this, let's put this here. If we say states US.sort, we'd see there's going to be a difference when we call the sort method. Okay, so this is what you have. You have everything sorted in alphabetical order. We have California, Georgia, Nevada, New York, Texas. Starts with the C, G, the N's, and then the T. What if we wanted to just reverse it instead? We could definitely do that. So let's just copy this code and do a reverse. Even though it was sorted before, now we just reversed it. So what was the last item became the first. What was the first became the last. And everything in between just picked their position. That's what the reverse method does for a list. So we've looked at the sort, we've looked at the reverse. How about we do a count? Let's do a count. To use the count method, we need to call our list, call the count method on our list, and we need to pass it what we want it to count. So let's say we want to count the number of times Texas shows up in this list. We can pass Texas in here. We'll put our print statements here as well. Okay, indeed, we had Texas just happen one time here. Let's say we made a mistake and we added Texas multiple sake of learning. Let's do this. If we run this, you see that this number is going to change from 1 to 2. Let's change that. Let's see. And there you have it. This is how you use the count method. You can use it to count the number of times something exists in a list. Okay. What if you try to use it to count something that does not exist in the list? So obviously we see that this has states in the US. Let's change this to, let's see what we get there. You'd notice that we don't have a spelling of Texas like this. And so it shows us that the count of this is actually 0. Okay, let's print our list and see what it currently looks like. Okay, we see we have Texas, New York, Nevada, Georgia, California. Let's say I want to get what is at the last position, or I know that I have California there. I just want to know what its index position is. We can use the index method to do that. So let's say index. All we just have to do is call it index. And if we print this, let's run this. We see that California is at index position 5. And that is true. 0, 1, 2, 3, 4, 5. This is what the index function does for us in the list. Now, in this video, we've talked about the index function, the count function, reverse, and sort. We've learned a lot on when to use it, how to use it. So I'm excited to show you other videos in this course where we look at other cool stuff. Thank you for watching, and I'll see you in the other videos. In this video, we're going to look at the different ways you can remove items from a list. We're going to start with a list of my favorite fruits, or just fruits in general. I will take turns trying to remove different items from the list. Let's just start with that. So we have here a list of different fruits. Let's work with pop. Let's print out the fruits first before we start removing stuff out of it. Print out this, we can run it, see what that looks like. So we have this outcome here when we run this. Cool. So first, let's remove the last fruit added. So we can remove the last fruit added, which is strawberries in this case. To do that, we're just going to call on the pop method without passing in any argument. And let's do this. If we run this, you notice that we no longer have strawberries in the same list. It's been removed. One thing about pop that makes it very unique is it not only removes the item, but it also returns it. So if we were to do this and give it a name, say removed fruits, we can actually print remove fruits. I would see it being stored there. Remove fruits, and we print fruits. Okay, let's run this. And this is what we have. We have our initial list: orange, guava, banana, mango, strawberries. We carry out our first pop and it becomes this new list. Then we carry out another pop, but this time we give the outcome or what's being removed. Fruits, mango, and then you see that mango just goes missing from here. Now, if you don't pass a position index to pop, it's just default to removing the last item. But pop is so powerful that it's still going to work if you pass in a particular position. So let's do that here. Can pass in a particular position. So guava, position 1. Guava is about to go missing. Let's see. We said, okay, whatever is in index position 1, take it out and just return what's left. And this is what we have. This is how you're able to use the pop method for a list. Currently, this is what our list looks like. We have just orange and banana. Let's say I just decided I no longer like bananas and I want to remove it out of the list. All I have to do is just call on fruits dot remove banana. And if I print fruits, this is what we're going to get. So let me show you. Run this. Yeah, and this is what our list has been reduced to. One key difference you'd notice is for you to use pop, all you need to do is provide the index or provide nothing and it will get the job done. But whenever you use the remove, you need to provide the name of the item. So that means you kind of have to know what's in the item for you to be able to do this. That's it. Thank you for watching, and I'll see you in another video where we learn some other list methods. Welcome. In this video, we're going to talk about the copy method and clear method for the Python lists. I've already defined this list here. So it's a simple list, car manufacturer. It has some car manufacturer names: Lexus, Toyota, BMW, Ford. Sometimes when you're writing software or you're solving a problem, you might want to make a copy of a list. And so I'll show you how you can do it. Let's call this new list. This is going to be this dot copy. Let's print car manufacturer. If we run this, we see that they essentially are identical. Let me make a change to car manufacturer here. Let's say I take out Ford, just do a pop. You'd see that the new list is still the same, but if I print the car manufacturer again, you'd notice there's going to be a difference. Let's run this. you see when we print the car manufacturer, Ford is gone, but when we print the copy, it's still the same. So this is one way of a list. Instead of doing it manually and recreating it, you can just copy a list and it has its own independence. Next, let's look at how we can clear an entire list. So let's look at this car manufacturer list. We know what we have there. We have Lexus, Toyota, and BMW. Let's come here and just call on the clear, and then we can print it again. See what we get. Let's run this. Now you notice that it's now empty. So if, for example, you have a list, you just want to start afresh, you don't want anything in it, you can use the clear method to do that. In this video, we looked at the copy and clear method. Do with it. I'll see you in another video where we learn some more interesting stuff. Thank you. In this video, we're going to talk about the data structures called dictionary. A dictionary is a special type of data structure in Python, which is very similar to the real-world dictionary. You can think of it like it's a digital organizer where you can store different information using a key and a value pair. So you're going to use the key to unlock the position of where the value is kept. We know that programming is just a way to tell a computer about the human world, and that's why a data structure like a dictionary actually exists. If you think about the real-life dictionary and the Python data structure dictionary, they're actually very similar, because in a real-life dictionary, you have your keys. Like in this image here, you have your keys, the words that you're searching for, and then the value is the meaning of the word. So also in a dictionary, you have the key and then you have the value. So it's the same way you can represent a dictionary in real life. That's just how it is in the data structure of Python. In a real dictionary, when you want to find the meaning of the word, you use the key to get to the meaning. So also in a dictionary in Python, when you want to get to the value, you're going to use the key to get to the value. Every data structure has a unique way of getting to the data hidden in the data structure. When it comes to a dictionary, the way to get to the value, the important stuff, the treasure, is to use the key. Whereas in a data structure like a list, to get to the actual value in the list, the element of the list, you can use the index position to get to that value in the list. Whereas in a dictionary, it's very different. This makes sure that the dictionary has a very different use case and it can be used for different tasks, which we're going to talk about in these future slides. What you have on the left is just an example of how you can add an entry to a dictionary. What you have on the right is how you can get items out of a dictionary. You notice on the right, to get to the value of a dictionary, you're going to use the key to unlock the value. As with every other data structure, you need to always have a way of deleting entries, updating entries, and managing the data in your data structure. The dictionary is not very different in that. We have ways in which you can use to update the dictionary and delete entries from the dictionary. If you want to check for membership in a dictionary, you can use the in keyword or the get keyword. And we're going to see that in the code along section. As with every task in the real world, there might be the need for you to carry out a repetition. And so also Python comes with handy functions or handy approaches that you can use to go through every single item in a dictionary. This can be achieved using the for loop and the items method of the dictionary. What you have here are just some of the most common dictionary methods. If you had to remember 4 functions, these are some of the functions you should remember when it comes to dictionary. What we have here are the most common dictionary methods. You have the keys, the items, the values, the get, pop, update, and copy. In the code along section that comes after this, we're going to go through every single dictionary method. There are not too many of them, so don't worry about it. Thank you for watching this video, and I'll see you in another one. In this video, we're going to look at example is just going to be an example use case of how you can use a dictionary. You just use a dictionary to store a person's name, their age, and the city they reside in. So let's say my dictionary, and we're passing a key. Every dictionary is made up of key value pairs, and we can say age, Miami. And this is an example of how you can define a dictionary. it has the key value pair. We have the key here, the name, and this is the value that maps to it. We have the key age. This is the value that maps to it. We have the city, the value that maps to it. We can add one more stuff. Let's add hobbies. And this is what our dictionary looks like. We have one more key that says hobbies, and the value of the key is actually a list. You have traveling, football, chess, cycling. Okay, let's move this out there. And this is our dictionary. If we use the type function, say type I underscore, if we run this, we'll see what the outcome is. Actually saying that this is a dictionary, which it is because we defined it. There are several methods that you can use with a dictionary. So we're going to go through each of them one by one. Let's start with the keys. If you do print my dict.keys, what this function does, keys in the dictionary. And we can also look at what the print of that will look like. We can pass this here. Let's run this. And there you have it. You see that the outcome of this key method just give us the name, age, city, and hobbies is in this dictionary. And when we check the type, we see that it's of class dictionary keys. And that'll be important in the future when we go into iterating through a dictionary. We know what our dictionary looks like now. We have it defined here. How do we now extract the value? Say, for example, you want to extract age. There are several ways we can do it. I'll just show you one of the ways and I'll show you the other way. So we can extract it and just do this, pass in the key name. Okay. Now if we just print this, say my name is, and this is how we are going to be able to extract it out. You see that we use the square brackets notation. We get the dictionary name or the variable representing the dictionary, pass in our square brackets, and within the square brackets, we pass in the name of the key as a string or whatever it is. And yeah, let's run this. See that with this, we're able to extract the value that was attached to the name key in this dictionary. There is another way we can do this, and it's using the get method. Using the get method, we can do the same stuff using the get method. So instead of using the square brackets, you can use the get method to get the item in that dictionary. For that, we'll just say .get, close this properly. The get method is a very special method in the dictionary because it allows you to access the values. But what if the key is not in that dictionary? How about we try to do this with a key that we know doesn't exist? So we know in the dictionary, when we go back to the top, we have name, age, city, hobbies. Let's say we ask it to return gender. We know gender is not there. We know it's not something that is provided here. Let me show you. You see that it just returns a none. So get returns a none, not in dictionary. We've seen here that that's what it does. It's going to return a none if that key is not present in the dictionary. What happens if instead of using the get method, we try to use the square brackets to get a key that does not exist? What do you think will happen? Let's check it out. Put a square bracket here. It's a square bracket. And let's run this and see what we get. Now, see if you try access a dictionary key that does not exist. In this case, we don't have gender here. We have name, age, city, hobbies. You're going to get into a key error because it doesn't exist. This is where the get method is very useful. As you build software, you may want to use this get ahead of this one because this get method is more gracious than indexing with the square brackets. Okay, so we've looked at what the get method can do. Let's look at some other methods in the dictionary. Let's say we want to get all the values in the dictionary. Okay, let's start out by printing the dictionary itself. We can just run this. This is what our dictionary looks like. If we just want to get all the values, we can just print using the value method. We'll call on my values. Let's run this. If we go back to our definition of the dictionary, you see we have Olabode, 100, Miami, and then we have a list as the value of the hobbies key. So that's what the values function does. It just returns a view to everything here. And if we check the type, we'll see that it's its own specific type as well. Let's check the type of this, what data type it is. If we run this, we see that this is dict values type. Another function is the items function or the items method. Let's get items, call items. So we have our dictionary here, name, Olabode, age, 100, city, Miami, hobbies as a list. When we call on the items method, we see that it returns a sequence of the pairing. So the key, the value, key, the value, all put in one object together, and everything is put into a sequence object here. And we see that it belongs to this class when we call on the type method. This becomes useful when you want to use a for loop with a dictionary. We'll get to that in the future. Right now, don't worry about it. We're just going over the different methods of a dictionary such that whenever you encounter it in production code anywhere, you won't be surprised and that will not be your first time of actually seeing it. Let's look at how we can remove items from a dictionary. Remove items. Start with my dict. The first method we can use is the pop method. And then let's print it after this has been done. So print before and then print after. Let's run this. When we look at the pop function, we pass in the key that we want to remove. If we go back to the original dictionary, we see that there's a key called age and the value is 100. Now when we call on this pop, it's going to remove that and also the value associated with it. Let me show you what that looks like. Let's run this. You notice you have age in this dictionary over here, but you don't have age in this dictionary. This is because we use the pop method to remove the age key and its value as well. So whenever the key goes, the value goes as well. Another way you can use to remove item from a dictionary is the pop item. But before we do that, let's just add one more element back. Let's add the age back again. So I'm going to come back here and just add my dict, pass in the key age. I would give it to, let's say I'm 50 years old. Let's print this out. So we're going to have age back in there. There's a special function to remove the last inserted item, and that is the pop item method. And you can return it as well. Let's just say last is going to be my dictionary item, and we can print this dictionary and see what we get. You'd notice that the age is gone. It's no longer there. So you'd see here that we're able to remove the last added item using the pop item. And when we print it out, we see that this is what's removed from the dictionary. If you come here, you'd see this is no longer there. It was the last added item, but it's no longer there. We've seen how to use the pop item and how to use the pop. We looked at items, values, we looked at the get, and we looked at how to define a dictionary. We can go ahead and try to use the update method. Let's say update method dictionary. The update method can serve two things. It can either add to the dictionary if the key does not already exist in the dictionary, or if the key does exist, it can change its value. So looking at the dictionary that we have here, name, age, city, key, say profession. So I'm going to define a new dictionary here and say new is going to be passive key profession, say data science, and if I add another key height, just going to put this 5 foot inches. I can add it here and just say age is 40 and my name, let's say I want my name to have a Sa in front. I'll just say Sa Olabode Olamo. Okay. Let's take a break to see what we've trying to do here. We have a new dictionary. This is going to be a new key because it's not in the other dictionary. This is not in the other dictionary as well. We're putting the age back in there and I'm updating the name. So what we should see is those keys that have not been in that dictionary should just be added. And since we already have name there, it should just change the value for us. So let's come here and print this out first before we perform the update. Let's run this. And so we have name, city, hobbies. We don't have age there. Now I can just go in and just go to my dict, update, and pass in new dict. Now if we print new dict, print, we should get something. So let's run this. Okay, let's put a line to draw. We are. Let's do this. Okay, let me run this. So before the update, my name was just this. After the update, my name becomes this. You'd also notice that we didn't have profession in the original dictionary. neither did we have the height, and we didn't have the age because we had taken it out previously. That's what the update function can do for you in a dictionary. It can add a key that does not already exist, but if the key already exists, then all it just does is an update. In this video, we've learned quite a bit. In the next video, we're going to look at the remaining dictionary methods and learn some new cool stuff. Thank you for watching, and I'll see you in another video. All right, welcome back. We want to look at these 4 methods in the dictionary: set, default, from keys, clear, and copy. Kind of have an idea of what clear and copy does, so that's totally fine. We're going to look at this set defaults first. Now with set defaults, what it does is it goes into your dictionary. So we know that we have a fresh start. It goes into your dictionary and attempts to bring out the value from a key if it exists in your dictionary. If it doesn't, it adds that key to your dictionary. Let me show what I mean by that. So looking at the dictionary, I have my name, profession, height, and age. Let's say I want to add my weight, my 600-pound weight. Okay, so I can just come here and go to my dictionary dot set default. Let's test it with something that we know exists. So let's say name. So if there's no name, just put this there, some random name. Okay, let's do set defaults. The method first searches for this key, and we say, okay, yeah, we do have name in this dictionary, and then it just returns what it is. Returns my made-up name, Sir Olabode. In this case, because name already exists as a key in the dictionary, it does return the value. If, however, it was something else and it didn't exist, let's say instead this is my weight, it's first of all going to check for if I have weight as a key there. If not, I would say return 600 or pass this in. Let's see what we get. You'd notice it returns 600. You see, I didn't have weight as a key in the dictionary, but then what it does is it realizes that, okay, weight is not a key. So I'm just going to add it in, and it gives it a value of 600. It's a very, very neat method because it does multiple things at once. It first checks if a key exists. If it exists, it just returns the value. And if it doesn't exist, it can add it to the dictionary. That's what the set default does. Copy just makes a copy. So let's just look at copy. Let's make a copy. You can call it new copy. It's going to be my dict copy. If we run this, we can see what we get. Okay. So you see here, it essentially just copies this entire dictionary. So let's clear this old dictionary. To do that, we just need to come here, clear, because we want to start afresh. And if we print this, it's going to be empty. Let's run it. See that you have an empty dictionary there. Good thing we made a copy, so life just continues. Let's copy this. Let's show that we still have it as a copy. Let's see, this dictionary has been cleared out with the clear method, but we still have a copy of it, which is why the copy method is extremely important. The from keys method is a quick way to create a dictionary given what you want your keys to be. In this case, we have a sequence of characters that we want to be the keys of the dictionary. The dict object from keys, we're essentially saying create a new dictionary based on these keys. We have to pass in what keys, the sequence of keys we want, and then give it a default value. Let's see what this looks like. You'd see that we created a very quick dictionary using just what our keys to be as a sequence, and we called from keys, and we're able to generate this. Of course, if you want to now change these values, you can now call on the update method to change those values. We've learned quite a bit in this video. It was fun teaching it. Thank you for watching, and I'll see you in another video. All right, welcome back. Set default, from keys, clear, and copy. Kind of have an idea of what clear and copy does, so that's totally fine. We're going to look at this set defaults first. Now with set defaults, what it does is it goes into your dictionary. So we know that we have a fresh start. It goes into your dictionary and attempts to bring out the value from a key if it exists in your dictionary. If it doesn't, it adds that key to your dictionary. Let me show what I mean by that. So looking at the dictionary, I have my name, city, hobbies, profession, height, and age. Let's say I want to add my weight, my 600-pound weight. Okay, so I can just come here and go to my dictionary dot set default. Let's test it with something that we know exists. So let's say name. So if there's no name, just put this there, some random name. Okay, let's do this. We see in this case with set defaults, the method first searches for this key and we say, okay, yeah, we do have name in this dictionary. And then it just returns what it is. Returns my made up name, Sir Olabode. In this case, because name already exists as a key in the dictionary, it does return the value. If, however, it was something else and it didn't exist, let's say instead this is, first of all, going to check for if I have weight as a key there. If not, I would say return 600 or pass this in. Let's see what we get. You'd notice it returns 600, but then what does it do to the dictionary? You see, I didn't have weight as a key in the dictionary, but then what it does is it realizes that, okay, weight is not a key. So I'm just going to add it in and it gives it a value of 600. It's a very, very neat method because it does multiple things at once. It first checks if a key exists. If it exists, it just returns the value. And if it doesn't exist, it can add it to the dictionary. That's what the set default does. Copy just makes a copy. So let's just look at copy. Let's make a copy. You can call it new copy. It's going to be my dict copy. If we run this, we can see what we get. Okay. So you see here, it essentially just copies this entire dictionary. So let's clear this old dictionary. To do that, we just need to come here and say my.clear because we want to start afresh. And if we print this, it's going to be empty. Let's run it. See that you have an empty dictionary there. Good thing we made a copy, so life just continues. Let's copy this. Let's show that we still have it as a copy. Let's see this dictionary has been cleared out with the clear method, but we still have a copy of it, which is why the copy method is extremely important. The from keys method is a quick way to create a dictionary given what you want your keys to be. In this case, we have a sequence of characters that want to be the keys of the dictionary. The dict object from keys, we're essentially saying create a new dictionary based on these keys. We have to pass in what keys, the sequence of keys we want, and then give it a default value. Let's see what this looks like. You'd see that we created a very quick dictionary using just these 2 lines of code. We passed in what we want our keys to be as a sequence, and we called from keys, and we're able to generate this. Of course, if you want to now change these values, you can now call on the update method to change those values. We've learned quite a bit in this video. It was fun teaching it. Thank you for watching, and I'll see you in another video. In this video, we want to talk about conditionals and control flow in Python. It's just a way of making your program a little more dynamic based on conditions. For example, you could look outside your window and decide, oh, it's raining. Well, I need to go grab my umbrella. And because we know that programming is all about copying what exists in the real world and having a computer do the work for us, we need to have a way to teach a computer to make certain decisions based on current conditions. In our example, the condition is the presence of rain. And we can see that if it's raining, then we need to go ahead and grab an umbrella. And that's just an example of the use of conditionals and control flow in Python. Like I've said already, conditional statements are essential for controlling the flow of execution in Python programs. Some examples of them are your if statements, your if-else statements. Don't worry about this. If it sounds like I'm speaking a different language, I'll show you how to do it in this presentation. And we're going to work a lot with it in this course where it's not going to be an issue. On the left, what you see is just the basic format of what an if statement looks like. It starts with the word if, if. You notice the I is small, the F is small as well, and it has to be exactly like that. And then you have condition. Condition means any expression, right? So an expression is just maybe you have some variables and some operators. That's your expression. And it checks if condition ends with a colon, and you notice it's indented, so there's a space over here where your code would now be within the if statement. So as an example, we have a variable assignment to x equals to 10, and then this if statement checks, okay, if 10 is greater than 5, which it is, do this. Print this statement, print x is greater than 5. That's it. This is just an example of how if statements works. Why do we need to learn this? If you're building a web application, you might want to check if a user is logged in to display different parts of the web app to them. So whenever you log into Facebook and you see that you log in and the look of Facebook changes, it's because somewhere in their code, there is some kind of conditional that is checking if you are the person that you say you are. So if you are logged in, it then shows you a different face. So understand now if statement works is very crucial for any scale of project or program that you want to write. We know the real world cannot just be modeled with just an if statement. So that's why we have the if-else statement. Essentially just saying, if it checks this condition, if it's true, great, execute the code there. If it's not true, do something else. In this example, we assign a variable age to 18, and the first check is if the age is greater than or equals to 18, print you are eligible to vote. If not, print you are not eligible to vote. So this is just a classic example of what the if-else statement is. Don't worry about it. We're going to have code along sessions where we're going to get into the weeds of how to write your if and else statements, and it's all going to be good. So far, we've looked at if statements, we've looked at if-else statements. If-else is useful where you have two conditions. If it's raining, grab an umbrella. If it's not raining, go out without an umbrella. But because we know that programming is all about modeling the real world, we know that most decisions are not that clear-cut. So that's why we have the if, elif, else statement. And it has this structure. You have your if statement, and you must have your else statement. You can have as many elif statements in between the if and the else, and that's totally fine. And it allows you to be able to model any kind of condition you have in the real world. With the if, elif, and else statements, you can model anything. So this is what makes it very, very useful and very important. But like I said, don't worry about it. The first time you're hearing this or seeing this, don't worry. I got you. We write a lot of code where it's going to become second nature to know when to use the if statement, when to use the if-else statement, or when to use the very extensive if, elif, else statement. Another way of capturing how complicated things can be is when you have your nested conditional statements. On the right side, you see we have a variable x to give you a value of 10. We see we have our first if statement, if x is greater than 5. And then within that if block, we have another if statement, if x is less than 15. You can always make things more complicated depending on what you're trying to model in the real world. For me personally, I like to keep it simple. Whenever I'm writing code, I try to use the simplest approach to write it for myself so that when I come and look at the code in 6 months' time, I'll remember what I was doing, and so that any other person that comes through my code can be productive and actually make contributions to my code. That's just one of the programming principles I work by. I like to use simple stuff, and that's what I want to teach. I want to teach you how to write code that is simple and effective as well as productive. So I'm truly excited to show you what that looks like. As we're trying to model different things in the real world, you might want to look into logical operators, so your and, your or, your not, and how to combine them within your code. Don't worry about it, we're going to have lots of examples of this, and you're going to get very comfortable with it. The reason I'm showing you this is I want to introduce it to you in a soft way first, before we get into the code along session, so that by the time we're writing the code for it, that's not going to be the first time you're hearing about this stuff. Now we've moved on to looping execution. So you have things like your for loop, we have things like your while loop. What they both do is allows your code to run repetitively. Look at what you have here. This is essentially the structure of a while loop. You have the while keyword. It has to be lowercase, exactly like that. Then you have the condition. So what is going to result in either a true or a false. If it results in a true, then you're going to go into the code and execute the code. That's the while loop. Now, the for loop is also another way to carry out iterations in your code to make your code run multiple times. And this is the structure of it. You have your for statement, for. You have a variable counter, in this case, item in iterable, or in the case of fruits is fruit in fruits. And you have your colon. You'll notice colon is used everywhere with your if statement, else statement, elif, if, your while loop, for loop, your function definition, you always have your colon. And what it does for the for loop, you want your code to run 10 times, you are most likely better off using a for loop than using a while loop. But don't worry about it. We're going to get into the weeds of how to use what and when to use what, either your for loop or your while loop. The main thing I want you to get out of this is to know that you use your for loop and your while loop to repeat your code execution. That's it. What we have here are just some control statements you're likely to find whenever you're writing your Python code in a loop. You have your break statements, you have your continue, you have your pass. I just want you to know that those words exist. And during the course of this series of lectures, we're going to get into examples of when you could use your continue, when you could use your break, and when you could use your pass. So in conclusion, we've talked about conditional statements. We talked about how combining your conditionals and your loops can allow you to write very powerful Python programs. I'm excited to show you in practice what we're going to do with everything we've learned here. So yeah, come join me in the next videos and let's make it happen. Thank you. In this video, I'm going to start with the most basic representation of the if statement. And that is, you first start with the word f. That's the first thing you do. Next, we need to have our condition. So let me just put the word condition there. Condition. Obviously, this is going to give me an error because condition variable name does not exist here. That's fine. Let's just print I am in the... It's an error. Let's just do it. Why not? Okay, so we got an error and says name error. Name condition is not defined. Okay, that's fine. Let's come here and say condition equals to true. Okay, let's do it this way. I am in the if is printed out. Now what this just tells us is this, whatever you have after the if statement needs to either become a true or a false. Okay, let's change this to false. So we're using the same variable condition. This time we change its value from true to false. And now we can replace condition with false. So it's saying if false, do this. This is not going to print because this block of code that is in this if statement will only execute if the condition is true. And you see nothing happens. So this is how if statement works in Python. Let's take another example. We know the drinking age is 21 in the US. Let's just create a new variable and put an age there. Let's say I'm 35. We're going to look at a different condition now. You know, here we just use a simple variable that had a value of true or false, a boolean. Let's make it a little complicated. So let's say if age is greater than 20, print you can drink. Before you run this code, what do you think the outcome is going to be? This is 35. The condition is 35 greater than 21. The answer is yes, which is true. 35 is greater than 21. Let me break this down again. Let's break it further. Make sure that we fully understand how this works. We can do this print. Okay. So we already know what's going to happen here. This I am in the if is not going to work. We have a new variable 35. We know this condition, we're checking to see if this age greater than 21, what is going to result to. So that's why we wrap it in a print statement. And we took the same expression and placed it here. Now, if this evaluates to true, which it will, we should be able to see this outputted somewhere. You can drink. Okay, enough talking. Let's see what happens. So we notice I am in the if doesn't print because this is false. Good. But then you see you can drink actually prints because this is 35. Okay. What if we change this to 21? What happens? Are you surprised to see that nothing printed here? You can drink didn't print. That's because 21 is not greater than 21. It is equals to 21, but it's not greater than itself. And so because this evaluates to false, this does not print. Okay, let's do a more complicated example. We're going to use the age, add country as a string, USA. Of course, we can say United States of America, but then that's too long. No one has time to type all that. Let's do one more if statement. Okay. Yeah, I want to check if you are greater than or equals to 21, because of course 21-year-olds can drink, and is USA. So let's run this and see what we get. But before we do that, let me explain what's going on. We know that all the if statement cares about is after the if and the space, anything in between the if and the space and the colon must evaluate to either true or false. It doesn't care how much stuff you chain in here, if you chain in a million, as long as whatever you have here can evaluate to. Now we see that in this case, if you are greater than 21, and your country is the USA, this should print out. Let's change this value. Well, we can do 18, or let's change this to 30. Okay, so we gave a value of 30 to age. We know that this is going to print because 30 is greater than 21, and this is also going to print. Okay, let's run this in the USA. Because this first condition, age greater than 21, yes, 30 is greater than 21. Okay, now this age greater than or equals to 21, already greater than, so that's fine. And country is USA. Now this is as statement by itself goes. But all you just need to remember is this fundamental structure. Once you press your enter here, it goes into the next line and it automatically does the indentation for you if you're using an IDE or a code editor. And that's it. I'll see you in another video where we look at the if-else statement. In the last video, we looked at the if statement. Now we're going to look at the if-else statement. So we're going to start with the basics, what the basic structure looks like. Once you press enter on your keypad, it takes you to the next line, but we want to start on this same line as the if. So you just type else and it's to do something else. Now, of course, if we run this, we know it's going to give us a problem. Let's just say condition is true. If we run this, it prints do something because this condition evaluates to true. We just put it there. It could be an expression that evaluates to true, but this is fine. So we say if true, do something else. For me to get do something else, all I have to do is just change this to false. And you see what we get is do something else. This is because this condition here failed. The condition evaluated to false. Therefore, the code in this block was not executed. Now, because all we're doing here is the if-else statement, the code just has to evaluate this. You would use the if-else statement if you have just one or two options. Do I go out or do I stay in? There's no in between. Or do I switch on the light or do I switch it off? So you're going to use this if-else statement if the decision you're trying to make has just two options. If it has more than two options, later on. And this is pretty much how it works. Let's do a little bit more complicated example here. Let's add age 22, country USA. Say if age greater than or equals to 21 and country is you, then you should print it is legal to drink. Else, meaning, okay, if for any reason any of these conditions are not met, what do you do? Print drinking is illegal. Now with this, we can play around with these parameters or these variables and see what we get. Now, if any of these doesn't meet the condition, it's going to return a false, and this is going to be printing. Okay, let's start with the country. Let's say Nigeria. The drinking age in Nigeria is actually 18. So realistically, this should be legal to drink. But just for this example, this is what we're looking at. Let's run it. Say drinking is illegal. We should probably put an exclamation point there. Okay. This evaluated to false because the country was not USA. If we wanted this to capture a scenario where to still give us a true, we could just say in put a list. With this arrangement, we'll see that it is going to be legal to drink this time around because we made a change to the if condition here. We kept the age as this. That's fine. The drinking age in Nigeria is 18. The drinking age in the US is 21. So we just took the maximum of the two, 21. And we made this statement to evaluate to true if the country is USA or Nigeria. Of course, you get the idea. You can add more countries here as well. The whole point is whatever is in between this space and the colon must evaluate to either true or false. Okay. Now if we run this, it's going to be it is legal to drink. So let's see. Now you notice this says it is legal to drink. So this is essentially how the if and else statement works. I want to encourage you to play around with other operators, other examples, see what you get. The more you work with it, the more you get a better understanding of how the if else statement works. Have fun, enjoy, and I'll see you in another video. Welcome to this video. We're going to look at the if else elif statement. Now, the if else elif is a little more complicated than just the if-else statement which we have here. The if-else is good if you have just binary decision making. Okay. If it's dark, I turn on the lights. If it's bright, I turn off the lights. Simple. Binary decisions. The real world is not binary. You probably have multiple options of what you have to look out for. And so this is where the elif comes in. For you to be able to use the elif, you first have to have your if statement. And then the next thing that needs to come after is your elif. And with your elif, you can put in your condition here. And let's just say I am in the elif. Now, if this evaluates to true, that's it. If it doesn't, and this doesn't as well, that's when we're going to have the else printout. So let's run this code and see what we get. Now, what we see here is of all these three print statements, all we got was do something else. Okay, let's make this a little more complicated. Add one more elif statement here. Let's do this. Let's change this to condition 3. You see condition 1, condition 2, condition 3. I made sure everything is false such that this 3 would not evaluate and it's just going to come here. Okay. Of course, you can have as many elifs as you want. Totally fine. I'm just showing you an example with just 2. You see what we print is do something else. Okay, let me change one of these conditions to true. So before I run this, I want you to let me know what the outcome is going to be. Let me make a change here first. I'm in the with condition 3. So just we can differentiate where we are. Okay, you see I am in the elif with condition 3. Why is that? That's because condition 3 is the only one that evaluates to true. Okay, what if multiple of them are going to happen? Now, if you thought both of these were going to execute, then that's not the case. You see, even though both of them were true, because it encountered this condition first, by the time it executes the code in here, it just comes out of this entire code block or this conditional loop. So it's very critical how you design your loop whenever you have elifs, just because the order in which you do this is critical because the code evaluates from top to bottom. And of course, in the case where it met condition 2 to be true, all it did was run this, I am in the elif, which we have here, and that was it. It never got a chance to look at this. It never got a chance to look at this either. And that's what makes it very, very interesting. Okay, let's look at a case where condition 1 is the only thing that is true. What do you think is going to happen? So let's change this to true, true, and change every other thing to false. Okay, let's run this. You notice do something is the only thing that I evaluated because it's the only thing that is true. So this is just the basic structure of if, else, elif statement. Of course, here, just because I want to get to the structure and explain it very well, that's why I simplified it by this. So evaluating long expressions. No, I want you to get the salient point, which is whatever you have after the space here and this column must evaluate to either a true or false. And then it would execute the code in the block. That's it. Even if we change all of this to true, it's only do something that will show. Okay, just this last example. Let's run it. And you see, because once this is evaluated, the code doesn't check these other conditions. It just skips it altogether. Okay, that's it. You've learned if, else, elif statements, and that's pretty cool. So I'll see you in some other videos where we learn some other cool stuff. Thank you. Welcome to this video. In this video, we're going to learn about for loops in Python and what they are used for. The for loop has a very basic structure. Let me show you what it looks like in comments first. It essentially just says for item. Let's just use that word item in list of items. Do some. This is the basic structure of a for loop. Let me just put underscore here so we know that this is one item. Now, based on this, there are several things you can do with a for loop. Every single data structure, so the list, the string, dictionary, sets, you have the opportunity to loop through those data structures. I'll give you an example. Let's say we have a variable. So let's just say name of favorite. Let's say Samantha. So we have a string that has a variable name of a cousin. And you see here we pass the value of Samantha. If we want to loop through this string, we could do it this way. We could say for I. Let's do this for now. I'll explain what I is, and we're going to change that in name of favorite cousin. Now you'd see the structure is very simple. You have the for in all lowercase. You have a variable name. You can call it anything, but it's a temporary variable name. We call it I in this case. We're going to change something else. Then you have the in keyword in. So it's like when you're searching for something in something. So you're searching for a pen in your bag, or you're searching for some cookies in the fridge. If you think of what comes after the in as a kind of container, then you see that it all starts to make sense. So the for loop just reads as a simple English statement saying, help me find the cookies in the fridge. So when you find the cookies in the fridge, what do you want to do? That's what happens in the loop here. So if you find the cookies in the fridge, you want to print them. I don't know why you want to print the cookies in the fridge, but let's go with that example. If we run this, let's see what the output is. Okay, you notice that what we have with the print statement is each character is printed one by one. And the reason for this is because what we passed in as the container is a string. And we know that a string is a collection of different characters, S, A, M, A, N, T in this example. So this is what the for loop helps us do. You'd notice that this I is a temporary variable. So if we try to, it works. That's because this I has a scope within the for loop. That's the technical terms, as a scope. Now we used I here and it's fine, but it's always a good idea to use a more descriptive name whenever you're describing your for loop. So instead of I, we know that each item here is a character. So we could just say for character in this. Now you notice that we're having an error with the I because the I doesn't exist anymore. Let's change this to character. Now if we run it, we'll see that it's still going to work. Okay, nothing changed. So you see the name here, it matters and it doesn't really matter. You can call it anything, and as long as you address it within the for loop, it's going to work. If on the other hand, you just don't use a descriptive name like I or something basic like that, then it makes it difficult for you whenever you come back to the code to understand what it's doing. So we've looked at the example of a string. How about if we look at a list? So let's define a list of the favorite cities in America. Let's just say fav cities. I put a list here. So for me, list, we're going to have the same structure. Let's loop through a list. Put a comment here and say loop through list. Okay, in this case, we are going to loop through a list. What do you think would be the individual item that is printed out? Remember, in the case of the strings, we had each character printed out individually. Now, in the case of a list, what is the individual piece of that list? So I want you to just take some time and think about what you think the individual will be. While you're thinking about it, let me show you how the structure goes again. So we'll say we could use I. Of course, we're going to change this. Just want to show you that it doesn't really matter what you call it. It's going to work regardless. So for I in fav cities, we could print I. Okay. Have you thought about what it's going to be? So let's see what it's going to be this time around. Now you notice whenever you loop through a list, okay, let me put a print to show the separation here. So we can do this. So I know, where one ends and the other begins. Let's rerun this. We see the line. So we know, okay, it's done. And this is for the other part. You see, in the case of a list, it goes through and takes the elements of a list one by one and acts on it. Now, we see we used I here, and we already know, that's not a very descriptive name. So let's change it to something descriptive and say city. This way, anyone that reads your code will know that, okay, you created a loop to search for cities in the container, where the container is a list of different cities. Now, what if we just don't want to print this? What if we want to print, say, the length? We can do that. As long as we operate on the city variable, we should be good. Let's do that. Say print, put a placeholder there as a length of. Now, this is just an example of the kind of functions. You can use any function that you can define or any of the built-in functions, but I'm just demonstrating with functions that we already know. So I want the city name to be here, and I want the length to be here. So I'm going to call the format function. And for the first part, I'm going to pass in the variable city. with a comma. Then I pass in the len of city. And if we run this, we can see that not only does it print the city, it also prints this statement as well. And it's able to carry out some function calls or calculation here because we call the built-in function len. We pass in the city. And we're also able to call the string method format, passing a string here with two placeholders. This placeholder 1, placeholder 2. The first placeholder is substituted with the city. The second placeholder is substituted with the length of the city. And this is what we have here. Now this just shows you that whenever you're working in a for loop, the structure is the same. What happens becomes different based on the kind of container you are actually looping through. So for now, we can look at one more example, but this step further within this for loop. Let's say we still want to work with the list. So let's copy this and another for loop, letter in city, print letter. Before I run this, what do you think would be the outcome? Now you remember that we have favorite cities is a list of strings. Let me show you here. So that means when you call this city temporary variable of these, which is a string. Remember when we looped through a string, we got the individual characters in that string. What that means is in this case, if you guess that it's gonna give you the individual letters, then you'll be correct. And that's essentially what we have. We print the city, in this case Austin. We carry out this computation. In this case, we look at the length. And now we just decide to spell the city a letter at a time, A-U-S-T-I-N. Once that's complete, it goes on out of this loop back here and looks at the next item in the list, which is Miami. So it prints Miami, carries out this simple computation, and then it loops through Miami, where you just have M-I-A. Once it reaches the last letter in Miami, which is the I, it comes out of this for loop, goes into this one, and does it all over again till it reaches Houston, and then it's going to stop at the last letter in Houston. So in this video, we've looked at how you could use for loops to loop through strings and lists. In future videos, we'll look at more complicated examples, but this should do for now. Thank you for watching, and I'll see you in other videos. In this lesson, we're going to learn about while loops in Python. While loop has a simple structure. It starts with the while command, then you have the space in between one space, and you have your condition. Now your condition could be replaced by this and it's still going to work. I'm just doing it this way just so you understand. And we have the colon. Once you're in the while loop, you can decide to do something. When do you use a for loop versus when do you use a while loop? Now, if you know that you want to repeat an action a specific number of times, you want to do something 5 times, you can use the for loop. It all depends on some conditions. Then you use the while loop. With the while loop, you have to be careful not to get into where you have an infinite. This to work, this has to become true. So in this example, I did this to be to 1. We know 41 is not less than 35. So if we print the condition, it's going to be false. Condition, we know it's going to be false. And so this do something will never be printed out. So let's run it and see. We see that only thing that is printed out is condition, which is false. And because while false, it's not going to execute what's in the code indentation. If we run this, we see that this is going to be printed out. So we see print false. Do something is not printed because the condition resulted in false. And we just say, I am outside. Let's just complete this to... Now, what if we do it in a way where this now becomes true? Let's see what happens. Let's say 35. We see 35 is less than 40. So we know this is going to result in true. Let me comment this out for now. Comment this out and we can print true. With a while loop, you want to be very careful that you don't get into a condition where this remains true because this will keep on going forever. I don't want to demonstrate it because it could be a little challenging to deal with. The basic way you're going to see a while loop being used is in a case where eventually we'll want this condition to result in a false. So you can see things like this. We know right now 35 is less than 40, but when it becomes 40, the condition is going to switch from a true to. Now we can make a change within the loop here and increase the age by 1. So when the first iteration happens, it says, okay, is 35 less than 40? That's true. Then 6. Then it comes back again and says, okay, is 36 less than 40? Let's do this here. We don't need this for now. We can pass this here. So starting from the beginning, we initialize with a value of 35 for age. We have this while loop that checks, okay, is the age 35 in this case less than 40? If it's true, go into the loop, print this, and then increase the value by 1. So if it's initially 35 plus 1, it becomes 36. Then it goes back here and says, okay, it's 36 less than 40. Prints the result of that condition, prints do something, and then it's 36 plus 1, that becomes 37. And it goes back here and says, okay, it's 37 less than 40, does the same thing, increases 37 by 1, becomes 38, and 38 condition is no longer true. We're going to see this change to true. So let's print age here, and we'll print what I'll say new age dot format age. Okay, let's run this and see the outcome. We see here that it starts with a value of 35 for age. 35 is less than 40, that's true. Then it prints do something, and then it prints 35. So that's the initial value. Remember, with a while loop, you need to have a way of making sure that this condition changes from true to false for most use cases. And that's what we do here. We increment it by 1. 36. So it goes back here and says, okay, it's 36 less than 40. That's true. 36 is less than 40. We can put a line here just so we know that we're moving to the next loop or next iteration. So we say it's 36 less than 40, so it's true. We say do something, we print 36, that's the current age. Then we increment the value by 1, and then we say the new age is 37. And then we have this printed out. Then since it's 37, we say, okay, it's 37 less than 40. We do the same thing up until the point where it gets to a point where the new age becomes 40. And you notice once the new age is 40, 40 is not less than 40. And so we don't see anything printed after new age is 40, because when this value takes on a value of 40, this results in a false, and the while loop is going to get terminated. And that's why we now get to a point where we are able to run this and we see I am outside the while loop. So this is just how the while loop works. You need it when you don't know how many times you need to carry out a calculation. If you know the number of times you want to carry out a particular computation, then you're going to use the for loop. Thank you for watching, and I'll see you in other videos where we build upon this concept.